Back in September 2021, Jared Isaacman took a crew of 4 to space in a Dragon for 3 days, and he is now going to be going again in Polaris Dawn. We are days away from that launch. And on this flight, they're going to perform an EVA and they're going to go higher than any human has gone in the last 50 years or so. The only humans that have gone higher, by the way, were people that were dead and cremated, such as Clyde Tombaugh, who went all the way to interstellar space. But I'm hoping that on this flight, we will get some live streams, we will get some live video, live reactions from the people that are doing this thanks to Starlink. Now, the first vision of Polaris Dawn we saw showed an astronaut spacewalking on a tether out in front of the spacecraft. But more recently, this was dialed back a little, showing a crew member extending themselves out of the hatch, holding on to these bars, which are called the Skywalker. And in the last day or so, an animation has been shared which shows a different capsule attitude. So I want to take these clues and put them all together to try to explain what I think the crew are going to be able to see on this flight. Now, the exact mission plan hasn't been laid out anywhere that I know, so I'm going to try and extrapolate from what I do know. And first of all, they laid out this rough timeline where they launch into this 190 by 1200 kilometer orbit, then they will raise it to a 1400 apogee, they'll bring it back down to 700, and then they'll perform the EVA. According to SpaceX's website, the launch plan is August 27th at 3:38 a.m. local time, and there's 2 other options at 5:23 and 7:09 a.m. Those are about 105 minutes apart, and I think that is for debris avoidance. Now, I had to think about exactly what debris they're avoiding, but it seems to me, based on the timing, this is very likely the recently broken up stage of the Long March 6A, which is about 800 kilometers up and has an orbital timing which kind of lines up with this. So if they launch at these times, they will try to basically keep that spacecraft on the other side of the planet relative to them so that they're not crossing its orbit at any time, which could, increase the chance of collisions. That is entirely speculation on my part, maybe someone will correct me. It is important to note that as they go above like 500-600 kilometers, the atmospheric drag becomes less and less, and there's more long-lived small space debris up there that they have to worry about, and that has influenced the planning of this mission. Like all the other SpaceX crew missions, they're launching northeast out of Florida and over the Atlantic in an inclination of about 51.6 degrees. This is very close to the space station inclination. There's no plans to go to the space station, nor would it even be possible with the Delta V they have, but they're using a similar launch trajectory because all of the contingency plans that are made in the case of an abort, those are predicated around this particular trajectory. So this means the minimum amount of changes to their plans. One thing that will change from this trajectory is because they're going into an elliptical orbit, they can't drop the second stage into the Indian Ocean, which has become somewhat normal. Instead, they have to bring it all the way around and have to drop it off the coast of Mexico instead. Now, we know the size of the orbit, we know the inclination of the orbit, we know what orbital plane it's launching into because we've been told the time, but we don't know where the apogee will be. That is, where the highest point from the orbit is, and that's called the argument of perigee. So, like you can see here that if I adjust the argument of pericenter, we are moving the high point around the orbit. But based on the fact that I'm told that the spacecraft is going to launch straight into this orbit, and not have a parking orbit, I think they're going to finish their orbital insertion burn at perigee, and that means the apogee will be, 50 minutes later on the other side of the planet. So if we assume that they launch at the first launch opportunity, that will make the orbit somewhat like this. So they're going to start out low over the Atlantic, about 200 kilometers up, and as they fly over Europe and the Middle East, their altitude is going to be increasing. And it'll be over the Indian Ocean where it really starts to reach the apogee on the very first orbit. So the point here is that the highest altitudes they achieve are all going to be in the southern hemisphere. An hour or so after launch, they're going to be passing over Australia and New Zealand. They should be high in the sky and they should be relatively visible. And so they'll more or less stay in this orbit plane for the rest of the mission. Now, initially they launch into a 200 by 1200 kilometer orbit. That means that the apogee is 200, the high point is 1200. Then they'll go into like the 1400 kilometer version, so they'll be slightly higher up. And so during the first day or so, they'll be able to get some snapshots off the southern hemisphere from, high altitude using their onboard cameras. But I feel I should point out the place where the Van Allen belts come closest to the surface is over the South Atlantic anomaly, and that's where they're going to be getting high, so they're going to be going deeper into the Van Allen belts than many other astronauts. But they're not spending enough time in there for it to be a serious problem to humans. It might generate transient glitches in electronics, but, they can fix that. So after this time at higher altitude, they're then going to come down to a lower altitude in preparation of the EVA. The reason they're not staying at the higher altitude, I presume, is because orbital debris becomes much bigger deal when you don't have a spacecraft surrounding you. You only have a thin spacesuit that needs to be flexible. So this is the visualization which was published yesterday, and it sort of changed my understanding of how the mission would be carried out. Now, first of all, we know it's not the same as the guy free-floating outside the airlock in the initial visualizations, but what we see here is the spacecraft is actually pointed down towards the surface of the Earth. And there's technical reasons why this makes sense. Think about it. If you are in that space capsule, and you're not going to go in the spacewalk, it means you can still look through the hatch and see the planet below you. If you are taking photographs from inside the capsule, you're going to have the Earth as the backdrop rather than the blackness of space. But on the other hand, we've seen that SpaceX suits don't have hugely flexible necks. If you look at the astronauts trying to look at the top of the rocket, they have to lean back because they can't adjust their neck. So the crew member that is performing the EVA is not going to look straight down at the Earth. They're going to be looking along at the horizon. And here's a Kerbal, by the way, visualization. Another thing that I realized, and I think I may have confirmed, is that they're actually going to orient the spacecraft so that the folding cover is pointed along the direction of motion, because that's where the highest probability of space debris arrival is. Therefore, that will actually act to shield the crew member in that orientation. Also note that during the EVA, they are going to have the Draco thrusters on the front of the spacecraft disabled, but they will still have some attitude control to maintain this orientation with respect to the planet below them. Now, to give you an idea of what the view will be like, it's actually kind of hard because you're probably watching this on a screen at a certain distance, and it's really not going to cover what the actual view through a person's eyes will be like. Sure, I've done like VR versions of what the visibility is like. Instead, I've created some sequences using Space Engine, and I've set the frame field of view to be exactly the same as an iPhone primary camera, or which is pretty much the same as almost any smartphone camera in terms of its field of view. So if you were to be outside the spaceship and be taking photographs, this is the kind of field of view that you would see, say, over the Mediterranean. This is how fast the Earth would appear to be moving for you as you swept over Northern Europe. Of course, what they see will depend upon when the EVA happens. This is what it looks like from 700 kilometers up, with South America on the left and Antarctica on the right. Here's South Africa with Cape Town in the middle there, stretching out to the south. Now, at the lowest point during the EVA, this is more what the Earth would look like. You notice the curvature of the horizon. Now, at 700 kilometers, note how the horizon is curved a whole lot more. And just for reference, at 1400, even bigger curve. This is, by the way, the area around Adelaide in South Australia. And if we expand it to the wide-angle lens, then yeah, sure, you're going to see a whole lot more. This is closer to what you might see with your eyes. Or, of course, your eyes looking out the window of the Dragon capsule, which, by the way, they've had to make a number of upgrades to the Dragon capsule specifically for this mission. First of all, they need new enhanced life support capability. They need the ability to go from a full air environment, 1 atmosphere pressure, 80% nitrogen, 20% oxygen, and reduce that over a day or so to be 1/3 atmosphere pure oxygen and no nitrogen. They need to depressurize that completely, open the hatch, and they then need, after closing the hatch, they need to be able to repressurize it and bring it back to regular atmospheric pressure with an oxygen nitrogen atmosphere. during the EVA, they're going to need to support 4 suits via the umbilical with extra cooling capability. So the suits, of course, have been upgraded from the regular IVA suits. First of all, they support pure oxygen at 1/3 atmosphere, and that helps with mobility because there's less gas pressure inside causing them to balloon. But it does mean that they now have issues with cooling because they have air-cooled suits rather than liquid-cooled suits. So, NASA likes to use liquid-cooled garments. The suits that they have on the Dragon don't have that capability, and since they're operating at 1/3 atmosphere, they're going to need to have faster airflow to help reject the heat. In space, keeping cool is actually really hard when you're a human body wrapped in layers of clothing that's generating heat. And again, I think the spacecraft orientation pointing away from the sun is going to help by shading the astronauts and stopping the solar radiation from putting too much in. Of course, they've got the heat from the Earth is actually reflecting back to them, so it's not, perfect. I believe they added some servos to help open and close the hatch, because this is like when they've previously opened and closed the hatch, they haven't been wearing the spacesuits, so that might affect their mobility. They figured that it's kind of important for the crew to be able to manipulate the hatch while they're wearing these spacesuits. Oh yeah, and this great image is actually a suit which is being tested, and to simulate the difficulty in getting rid of heat, they've basically put thermal gear over the top. The kind of thing you would wear while climbing Mount Everest is being worn on top of the spacesuit to simulate its difficulty in rejecting heat. Also, it's not clear how much this is going to be live streamed, because I know that they have this laser communications experiment, but the images they showed had a laser shooting out of the Dragon trunk. And I'm going to say, if this nose down attitude is what's being used, then the trunk is pointing out to space. So maybe there's a different way for them to communicate during this. It remains to be seen, and we'll probably find out.